Today we're going to begin lesson 6-1. I'm going to ask you that you get out your new math journal, Journal 2, and you are going to turn to page 265. So this is journal page 265 in journal number 2. Okay. So you're going to look at the math message. Question number 1 says, what number makes the equation below true? So I'm going to substitute the 1 in for x. If x is 1, is that a true number sentence? If not, try 2. Go ahead and put 2 in for x. Is it a true number sentence? If that doesn't work, try 3, try 4. Which of those 4 numbers makes the equation below true? And then explain how you found your answer. For question 2, you're going to work on that. And it says each variable in the equations represents a different whole number between 1 and 10. So the possible numbers could be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Those are the possible answers. A variable stands for the same number every time it appears. So that means if down here I have a D here and a D here, whatever number I put in for D here, it's going to be the same value here and here. The other thing is no two variables have the same value. So if I assign D, if I think D is worth 5, and I'm just completely making that up right now, if I think D is worth 5, then A, B, C, and E are not allowed to be 5. And then it says for each variable, tell what number will make the number sentences true. So you have to use your math knowledge and look at all of these equations. Okay, and you have to figure out what value is for A, for B, for C, D, and E. So that when you plug them into these equations here, you're able to solve all of those equations correctly. Give it your best shot. You're going to pause the video now, try problems 1 and 2. Once you're finished, go ahead and play the video. Let's move on to journal page 266. If you substitute a number for a variable in an equation and the result is a true number sentence, then that number is a solution to the equation. So for example, if I have the equation x plus 6 equals 7, and I try putting numbers in here, maybe I first choose x equals 3. If I put 3 in here, 3 plus 6 does not equal 7. Therefore, 3 is not a solution. Okay, so maybe I try x equals 1. And when I put 1 in there for x, 1 plus 6 does equal 7. Therefore, because it's a true number sentence, 1 is my solution. Okay, if we go back in our reading, one way to solve an equation is to try several test numbers until you find the solution. Each test number can help you close in on an exact solution. This trial and error method may not result in an exact solution, but you can get quite close. So if we look at our first equation here, it's right here. Let's go ahead and put a box around it. You should do the same on your paper. 1 over x plus x equals 4. If we cannot find an exact solution, we can try a number that's very close. So we said, let's make x 1. So we're going to go ahead and try x as 1. When I do that, I'm going to get 1 over 1. I try to erase some of this here. Hang on a second. So that I can hopefully do some work on the side here. Okay. So when x equals 1, I put 1 over 1. and that equals 1. And then when I take my value, 1 over x, which is 1, plus x, which is 1, I get 1 plus 1 equals 2. We wanted to equal 4 here. So how does 2 compare to 4? It is less than, 2 is less than 4, or sometimes I just write the words over here, it's too small. So if 1 is too small, let's make my number a little larger. Let's try 2. So when I fill the 2 in here, I put 1 over x, and we now said x is 2. And when I take 1 over x, which is 1/2, or 5/10, plus x, which is 2, and I add these numbers together, I get 2.5. So how does that compare to 4? Well, it's still less than, or it's too small. However, I'm noticing it got a little closer to 4, right? So let's go a little higher. Let's make x equal 3. When I put 3 in here for x, I get 1 over 3, which is the same as 0.33333 repeating. When I take and I combined my 1x, which is 1/3, or 3/10 repeating, and I add that to my x, which is 3, I get a total of 3.3 repeating. Again, my number is too small. It is less than 4, but I'm getting closer. So let's try 4. We keep going up. When I put 4 in here, 1 over x, which is 4, gives me 25/100. I combine my 1 over x, which becomes 1/4, or 25/100, with my x, which is 4, because here's my equation. And when I combine those, I get an answer of 4 25/100. Okay, or, sorry, I should have put a decimal there, but you get the idea. Now it's greater than 4, meaning it is too big. 3 was too small, 4 was too big. Based on the results above, it makes sense to try numbers between 3 and 4, because 3 was too small, 4 was too big. Now they noticed that when we used 4, we got 4 25/100. When we used 3, we got 3.3 repeating. So they said, you know what? It looks like the number is going to be closer to 4 than it is to 3. So let's go a little bit under 4. If I think about a number line, here's 3, here's 4. If I want to break it apart, remember how we had a decimal and zeros we learned earlier in the year? So in between 3 and 4 is 3.5, or 3 5/10. So here's 3 1/10, 2/10, 3/10, 4/10. 5/10 is there already. 6/10, 7/10, 8/10, and 9/10. So we chose 3 9/10 right here, and they put that in. 1 over 3 9/10. Remember that fraction bar means to divide. We're using our calculator for all of this. It's very important. Use your calculator, okay? When I put 1 3/9 there, and I divide, I get a decimal of 256 thousandths. Add it to my 3 9/10. And when I add those together, I get a little bit greater than 4. So it's still too big, but I'm getting closer, right? So they said, let's go a little smaller. Let's go down here to 3 6/10. If you look on my number line right here. So I highlighted that in red. So when we put 3 6/10 in, 1 divided by 3 6/10 gives me this decimal. When I add 3 6/10 plus 0 and 278 thousandths, I get an answer of 3 878 thousandths. So now my number is less than 4. Remember, up here, top. Here's what we wanted. It's now too small. So what I'm doing, if you remember playing that crazy game called Number Squeeze when you were in like kindergarten and first grade, or Monster Squeeze I think it was called, you were zooming in and kind of closing in on the number line. So if we look up here at the number line, and we put some other numbers on here. Here's 1, oops, I didn't space that out very well, did I? Here's 2, here's 3, here's 4, okay? 1 was too small, 2 was too small, so that wouldn't work. 3 was too small, which means nothing in here would work. And then we realized 4 was too big, so anything bigger than 4 wouldn't work. They tried 3 and 9/10, which was too big, so I squeeze in. They tried 3 and 6/10, that was too small, so any numbers below it don't work. I now know that my number has to be somewhere in between here. So maybe I will try something like 3 and 8/10. So go ahead and fill that in on your page. When I take 3 and 8/10 and I put it over 1, so that means 1 divided by 3 and 8/10, I get an answer of 0 and 263 thousandths. When I add 3 and 8/10, which is my x, and 2 and 263 thousandths, I get an answer of 4 and 0.63. So when I add those two together and I compare that to 4, I realize that it is greater than 4, meaning that it is too big. So if I come up here to my number line and I try 3 and 8/10, which was right here, I realize that's too big, so I'm going to zoom in some more. So therefore, my number now has to be between 3 and 5/10 and 3 and 8/10. So let's go and check 3 and 7/10. In my calculator, I'm going to take 1 divided by 3 and 7/10. And when I do that, I get 0 and 270 thousandths. When I combine 2 and 700, or 200, I keep saying that wrong, 270 thousandths plus 3 and 7/10, and I line up my decimals, I end up getting an answer of 3 and 970 thousandths. When I compare that to 4, which is what I wanted to equal, it is too small. So if that's too small, but 3 and 8/10 is too large, I would have to break my number down again. So here's 3 and 7/10, which is too small, and 3 and 8/10, which is too large. What's in between 7/10 and 8/10? Well, I add a 0, and we could break it down into 3 and 75/100. So if we try one more together, I can take and I can divide 1 by 3 and 75/100, and I get 0 and 26 repeating, so 26/100 repeating. Okay, and if I take it to the nearest thousands place, that would be a 6 and a 6, or I could round it up to 6, 7, close enough. When I take and I add 3 and 75/100, and I add 266 thousandths to it, I end up getting an answer of just over 4. Now, I know some of you want to keep going, and if you certainly want to, you're welcome to go just a tad bit smaller, maybe try 3 and 7400ths and see how close you can get. I know it becomes a competition for some of you. However, I think at this point it would be safe to say that we got pretty close to 4 when we used 3 and 7500ths. So this is the trial and error method, okay? When we have problems that sometimes we don't necessarily know how to solve, we use the trial and error method. So what I would like you to do is I would like you to turn to the next page in your journal. That would be journal page 267, and I want you to try problem number 1. See, the equation is 2y times y equals 47. See if you can figure out what y equals so that we get as close to 47 as possible. Good luck.